Welcome all of you dear students. This is the simplest and easiest way of teaching learning process in our most popular, most famous YouTube channel Physics Make It Simple by Dr. Rajendra from Padma Shri V.K. Patil Junior College, Pravaranagar, Loni. We are discussing the chapter Oscillations as long as 12 science is considered, and this is the lecture number 2. In lecture number 1, we have already discussed the concept of oscillatory motion, why oscillatory motion is a periodic motion and harmonic motion, and how the differential equation of linear SHM is to be derived. That all things we have learned in lecture number 1. The students, those haven't seen the lecture number 1, my humble request to all of you, listen the lecture number 1 and come here to listen the lecture number 2. In our lecture number 2, we have to derive 3 equations of 3 physical quantities. Number 1 velocity, number 1 acceleration, number 2 velocity, and number 3 displacement when particle performing SHM. Listen carefully dear students, out of these 3 physical quantities we are able to derive at first acceleration and not displacement. So I have written on the board the first article that equation of acceleration when particle performing SHM. While deriving 3 equations, remember dear students, always we have to derive the equation of acceleration first, because we are able to derive equation of acceleration at first instead of velocity and displacement. So how the equation of acceleration is to be derived, let us see. For that purpose, we should know the differential equation of linear SHM that I will write on the board. The differential equation of linear SHM is, I will write here, differential equation of linear SHM is given by differential equation of linear SHM is given by, that I will write here, which is equal to d2x upon dt square plus omega square x is equal to 0. And from this differential equation you will get the equation of acceleration, that is d2x upon dt square is equal to minus omega square x. This d2x by dt square we call it as acceleration, and acceleration is always denoted by small a, which is equal to minus omega square x. So this is our first equation when particle performing SHM. This is our first equation. We have to remember in any time while solving different numericals, as long as the oscillation is concerned, the particle performing SHM, acceleration of a body is given by d2x by dt square is equal to minus omega square x. This negative sign indicates acceleration is directed towards mean position and displacement is always measured from the mean position. That means acceleration and displacement are oppositely directed. Take a screenshot. This is the first equation. Okay. Then let me clean the board at first. Then we have to see what? Acceleration. We have already derived the formula of acceleration. Now we have to derive the formula of equation of velocity v when particle performing performing SHM. Listen carefully, dear students. While deriving the formula of velocity, we should know the formula of acceleration. So this is the starting point to derive the formula of velocity. So what is the formula of acceleration? What is the equation of acceleration? We know equation of acceleration is, we know equation of acceleration is, d2x by dt square is equal to minus omega square x. This is the equation of acceleration. So how we can modify this equation, that we have to see here. So we will write this like this: d by dt of dx by dt, which is equal to minus omega square x. D by dt of dx by dt, d by dt of dx by dt, d by dt of dx by dt, itself we get d2x by dt square. So what is dx by dt? What is dx by dt? Dx by dt is nothing but the rate of change of displacement, and rate of change of displacement is nothing but the velocity. So we will put here d by dt of v is equal to minus omega square x. D by dt of v is equal to minus omega square x, or this may be written as like this: dv by dt is equal to minus omega square x. This may be written dv by dx into dx by dt is equal to minus omega square x. What I have done here? I have multiplied by dx and divided by dx, multiplied by dx and divided by dx. There is no any change. There is no any change. Then again here dx by dt we got is velocity. So we can write like this: dv by dx, dv by dx, dx by dt is nothing but the velocity, which is equal to minus omega square x. This may be written as like this: v dv is equal to minus omega square x into dx. So take integration of this, we will get what? Integration of v dv is equal to integration of minus omega square x into dx. So integration of v dv is equal to v square upon 2 minus omega square is constant, and integration of x is nothing but x square upon 2 plus some integration constant c. This is the equation number 1. Observe carefully. By taking the integration on both the sides, we got v square upon 2 is equal to minus omega square is a constant term. Integration of x dx is equal to x square upon 2 plus some integration constant c. We have to find the value of c. To find the value of c, let us assume velocity of the particle v is equal to 0. So velocity is 0 when particle is at extreme position. Remember well, velocity is equal to 0 when particle is at positive extreme or negative extreme. So we can write like this: to find c, we can write here v is equal to 0 at x is equal to plus or minus a. plus or minus capital A. Capital A is amplitude and small a is acceleration. Remember well, dear students. So put these values in equation 1. You will get v square upon 2. Put these values in equation 1. We get what? 0 square upon 2, we get 0 here, is equal to minus omega square a square upon 2 plus c. That means c is equal to omega square a square upon 2. In this way, we get the value of integration constant c. Then now put the value of c in equation 1. We get what? Put the value of c. Put the value of c in equation 1. We get what? We get v square upon 2 is equal to minus omega square x square upon 2 plus omega square a square upon 2. 2 get cancelled and you will get v square is equal to minus omega square x square plus a square. Plus omega square a square. Then here we can write like this: v square is equal to, take omega square constant, you will get what? A square minus x square. A square minus x square. Then take square root on both sides. Take square root on both sides. Take square root on both sides. You will get what? V is equal to square root of this plus or minus omega square root of a square minus x square. This is the formula. So v is equal to plus or minus omega square root of capital A square minus x square. This is the velocity of a particle while particle performing SHM. V is equal to plus or minus square root of a square minus x square. Acceleration d2x by dt square is equal to minus omega square x. And then now we have to calculate, we have to derive the formula of displacement. Before that, take a screenshot. So this is all about velocity. V is equal to plus or minus omega square root of capital A square minus x square. Okay. Then we will proceed further. Equation of what? Equation of displacement. We have to find equation of displacement when particle performing SHM. Remember well, dear student, while deriving the formula of displacement, we should know the equation of velocity now. So starting point is nothing but the equation of velocity. So here I will make a title like this: equation of displacement. Equation of displacement x when particle performing SHM. We know, write the formula of velocity now. V is equal to plus or minus omega square root of a square minus x square. This is a formula of velocity. What is velocity? Velocity is nothing but the rate of change of displacement. So V is equal to dx by dt. So I will write here dx by dt. Dx by dt is equal to, take only magnitude. Neglect this positive or negative sign. We can write like this: omega square root of a square minus x square. So this may be written as like this: dx upon square root of a square minus x square. Separate the variables like this, and take an integration on both the sides. You will get what? Integration of dx upon square root of a square minus x square is equal to omega t. So what is integration of dx upon square root of a square minus x square? So here, sorry, we will take capital A square here, capital A square. Sorry, we will take capital A square because we have determined to indicate amplitude by capital A. So we take capital A here, capital A square, capital A square. So integration of dx upon square root of a square minus x square, you will get what? Sine inverse x upon a is equal to omega, sorry, integration sign is remaining here, omega is constant, integration of dt, and integration of dt is t plus phi. So this may be written as like this: x upon a is equal to sine omega t plus phi. Then x is equal to capital A sine of omega t plus phi. This is the equation of displacement. This is the equation of displacement. X is equal to capital A sine of omega t plus phi. V is equal to plus or minus omega square root of capital A square minus x square, and d2x by dt square is equal to minus omega square x when particle performing SHM. These are the three equations we should always remember, keep in mind while solving different numericals and while learning the oscillation very clearly. Take a screenshot. Then we have to see what? Two different cases of displacement when particle starts from mean position and when particle starts from extreme position. So let me clean the board at first. Let me clean the board. Okay. So I will write here two different cases. Two different cases. Number one, what is number one? When particle starts from mean position. When particle starts from mean position. So what is the equation of displacement? What is the equation? Two different cases of displacement. Two different cases of displacement x. Of displacement. Two different cases of displacement x when particle starts from mean position. Let us see here. So this is our simple pendulum. Okay, wait for some time. This is our simple pendulum. When particle is at mean position, there is no any angle. There is no any initial phase angle. Phi is initial phase angle and omega t plus phi is called as phase of SHM. So what is phase of SHM? That we will see in the next lecture. But before that, phi is called as initial phase angle. When particle starts from mean position, this is a mean position when phi is equal to 0, or this is also a mean position in upward direction, in which case the phi becomes how many? From 0 to here, phi becomes pi radian or 180 degree. So when the particle starts from mean position, listen carefully dear students, when the particle is at mean position, either phi is equal to 0 or phi is equal to how many? Phi is equal to 180 degree. From this to this, phi is equal to 180 degree. So I will write here, either phi is equal to 0, phi is equal to 0 degree, or it is 180 degree or pi radian. So what is our formula of displacement? X is equal to capital A sine of omega t plus phi. Capital A sine of omega t plus phi. Then put phi is equal to 0. Put phi is equal to 0 degree. Then what we get? X is equal to A sine omega t. This is our equation. When phi is equal to 0 degree, then we get x is equal to A sine omega t. Or when phi is equal to 180 degree, then what we get? Let x is equal to capital A sine of omega t plus pi. So what is the formula of sine of omega t plus phi? This may be written as like this: x is equal to A. What is sine of A plus B? Sine of A plus B. Use the formula. Sine of A plus B is equal to sine A cos B plus cos A sine B. Sine A cos B plus cos A sine B. So here sine A cos B plus cos A sine B, that is sine of omega t plus pi. This may be equal to 0 because cos pi is equal to 0, and here we get what? X is equal to A cos of, so what is this? Cos of pi is equal to minus 1, and here sine omega t. So we get minus sine omega t. So you will get what? X is equal to minus A sine omega t. So either the equation x is equal to A sine omega t or equation x is equal to minus A sine omega t. By combining these two equations, you will get what? X is equal to plus or minus A sine omega t, like this. This is the equation when particle starts from mean position. Particle starts from mean position. At that time we get x is equal to plus or minus capital A sine omega t. When x is equal to A sine omega t, then particle starts from mean position to positive extreme. And when x is equal to minus A sine omega t, at that time particle starts from mean position to negative extreme. So when particle starts from when particle starts from mean position to positive extreme towards positive extreme, then you will get plus A sine omega t. When particle starts from mean position towards negative extreme, then you will get minus A sine omega t. Or in general we can say that x is equal to plus or minus capital A sine omega t. This is a formula when particle starts from mean position. That's all. So take a screenshot. This is the first case. Okay. Then listen carefully dear students. It is not necessary to derive all these formulae as long as your examination point of view. Only remember, when particle starts from mean position, only remember this formula. X is equal to plus or minus capital A sin omega t. This is only I have derived for your understanding how the formula is coming. That's all. Then we will take the another case. Let me clean the board at first. The another case is particle starts from extreme position. Particle starts from extreme position. Particle starts from extreme position. Extreme position. I will repeat again. When particle starts from mean position, what is the initial phase angle phi, dear students? What is the initial phase angle phi? Initial phase angle phi is equal to 0 or pi. Initial phase angle phi is equal to 0 or pi. So when the particle starts from extreme position, at that time initial phase angle is either pi by 2 or 3 pi by 2. So here initial phase angle is phi is equal to pi by 2 or 3 pi by 2. Pi by 2. That means particle is already extreme position. See here, when the particle is at extreme position, see here, when the particle, this is mean position, when the particle is at extreme position, phi is equal to pi by 2. Then how 3 pi by 2? Initially it is on one side of extreme position, pi by 2. Then here 2 pi by 2 and here 3 pi by 2. Let us listen carefully again. When particle starts from extreme position on one side, the particle having initial phase angle from mean position to extreme position is pi by 2. Then when particle is on another extreme position, then this is already pi by 2. From mean to extreme, 1 pi by 2, this is 2 pi by 2 and this is 3 pi by 2. So we can say that phi is equal to either pi by 2 or 3 pi by 2. And how the equation is coming, that we have to see. So let us derive the equation. We know x is equal to capital A sine of omega t plus phi. Put phi is equal to pi by 2. Put phi is equal to pi by 2. So x is equal to capital A sine of omega t plus pi by 2. Then we can derive this. Capital A, then what? Sine of A plus B. Sine A cos B plus cos A sin B. Cos A sin B. This cos of pi by 2 is equal to 0. So this is completely 0. Sin of pi by 2 is equal to 1 and only cos of omega t is remaining. So x is equal to A cos of omega t when particle starts from extreme position. Then put phi is equal to 3 pi by 2. X is equal to capital A sine of omega t plus 3 pi by 2. This may be solved like this. Capital A sin A cos B plus cos A sin B. Again see here, this is 0 because cos of 3 pi by 2 is 0 plus cos of omega t and sin of 3 pi by 2 is equal to minus 1. So sin of 3 pi by 2 is equal to minus 1. minus 1, and this is cos omega t. So we get minus cos omega t. So you will get formula A is equal to minus A cos of omega t. So from these two equations, we conclude that when particle starts from extreme position, then the equation of displacement is either x is equal to capital A cos of omega t, or x is equal to minus A cos omega t, or by combining these two equations together, we will get x is equal to plus or minus A cos of omega t. This is the equation. When the equation is x is equal to capital A cos omega t, then particle starts from positive extreme towards mean. When x is equal to plus capital A cos omega t, then particle starts from positive extreme towards mean. Listen carefully, I will repeat again. When x is equal to plus capital A cos omega t, then particle starts from positive extreme towards mean, and when x is equal to minus A cos omega t, at that time particle starts from negative extreme towards mean. Combining these two equations, we will get x is equal to plus or minus capital A cos of omega t when particle starts from extreme position. When particle starts from mean position, x is equal to plus or minus A sin omega t. So this is all about today's lecture. We have learned the equation of acceleration, velocity and displacement when particle performing SHM, and also we have learned two different cases of displacement. Number one, when particle starts from mean position, and number two, when particle starts from extreme position. Take a screenshot, and now we will stop here and we will meet again for the next lecture. Goodbye.